Is that it for is that okay for you, David? Did you
that's fine. I'll share my screen now. Make sure that's working.
Okay. Yep. Fine till it works. Yep, I can see it okay. Excellent. Okay, I will turn my cam and mic off.
Thank you, Robert. Good afternoon, everybody. My name is David Ray from CPL Activated Carbons. Some of you may have been at my presentation yesterday morning. I did a very brief overview of the use of carbon filtration, mainly focused on CHP engine protection. But I have this opportunity this afternoon to do a much deeper dive into the use of activated carbon for biogas and biomethane applications, which I hope you find interesting, focusing on carbon selection, filter selection, with some case studies. So a quick introduction to my company, CPL Activated Carbon. Bit about our capabilities. We obviously supply the activated carbon itself, hence the name. Our brand name is FiltraCarb. Wherever possible, we recycle spent carbon. It's a filter media, so when it gets spent, we try to recycle it. And our process is called Regensis. I'll talk more about that and the benefits of that. An increasing part of our business is the supply of mobile carbon filters. You can see some examples of our larger, those are liquid phase units as it happens. So we call those our clean flow range. Gas phase ones are called Voxorbers, liquid phase are called Aquasorbers. I'll talk more about those. We also supply an engineering capability in terms of design, manufacture, and install. So basically, if a customer needs to use carbon and hasn't used it before, we can supply all the pipework, valves, connectors, flexible hoses that are required in order to plumb out one of our filters into your system. So we're basically a one-stop shop for carbon filtration. Obviously, I'll talk about our experience in biogas projects, which is extensive. I'll talk about the benefits of carbon reactivation and the benefits of using large filters rather than perhaps smaller filters. Talk about lead and lag. I'll talk about what that means later. Basically, it's when you have more than one filter and you have one up front of the other. So one does the hard work and the second one acts as a polishing filter. It gives you a number of process and performance advantages. I'll go into more detail on our engineering capabilities because that's a bit of our unique selling point. And then I'll go into more detail on carbon selection. So particular for the biogas audience, we're talking siloxanes, VOCs, and H2S abatement. I'll talk about the range of products we have, why you would select a particular product. Okay. So brief intro, CPL Activated Carbons. We are a leading supplier, a manufacturer, and reactivator of carbons. We've just celebrated our 30th birthday. We were formed in 1990 as Carbon Link Limited. That's still our legal entity name. Some people still know us as that name. We were acquired by our parent company, CPL Industries, end of 99 to form CPL Carbon Link, and now we're known as CPL Activated Carbons. We've been reactivating spent material here in the UK since 2013, so we have a lot of experience handling spent activated carbon and, as I say, wherever possible, recycling it for reuse by our customers. 2018 was a big year for us in terms of expansion. We've more than trebled our capacity to recycle spent carbon, what we call amber waste carbon. So that is industrial processes like biogas, odor control, and on the liquid side, it'd have wastewater and remediation, that type of thing. That year, we also acquired a company that manufactures our mobile filters. They're called CPL Icon, and they're based in Chesterfield here in the UK. I think I'll talk more about filters later. We're quite a small team, but we're very experienced. Last time I counted between us, we have more than 175 years in the carbon industry. So we are, we like to think we're the experts in carbon filtration. You probably know carbon is used in many purification applications, from drinking water through to gold recovery and everything in between. But certainly here in the UK, we are market leaders in a number of sectors like biogas, flue gas at energy from waste incinerators, remediation projects, and overseas we're very big in edible oil, so it's particularly olive oil and other edible oils that need purification. So a bit of our facilities and capabilities. Our main manufacturing site is in Immingham, which is on the east coast of England, here in the UK. We have two separate carbon reactivation facilities. The big one is amber waste. Let's say this is for industrial spent material, including biogas carbons. We have a capacity of 8,000 tonnes per year of that, so that is a big unit. And have a separate unit for carbons from drinking water and food grade applications. It's a smaller unit, but it's completely separate. As you can imagine, it's very important to keep those two streams separate. And it's a large site, and as the business grows, we have plenty of space to grow with it. So We also manufacture a number of our own activated carbons. There's the impregnated grades for removal of things like hydrogen sulfide and ammonia. And I'll talk a bit more about what impregnation is and what the different types are later. But we do produce some of our products ourselves here in the UK. We have a strong engineering capability in terms of carbon vessel design and fabrication, plus ancillary pipework, as I mentioned before. And we have multiple warehouses and transfer stations, both here in the UK and in France. And we can also supply our carbon and vessels into Spain as well, if required. Not so relevant for biogas, but we produce powder activated carbon, PAC, which is typically used for flue gas treatment in energy from waste facilities and in edible oil. And we have multiple grinding facilities here in the UK to support that business as well. We originally registered in the UK, but because of Brexit, we also registered we have a subsidiary in Spain, in Madrid. So we think we're pretty much Brexit proof in terms of supplying carbons to our European mainland customers. And of course, as you would imagine, we have the latest quality and environmental accreditations. So a bit about the biogas sector. We have many customers in the biogas industry from the various subsectors, for example, landfill operators, wastewater utilities, traditional agricultural AD sites, food waste sites. And we also supply a number of service providers who do more of a complete package into the biogas sector. It could be involving engine maintenance or other services. We can supply full carbon and vessel service or just carbon only. And that's important because we can supply carbon basically anywhere in the world if required. You can see some of our filters on the right-hand side there. That's at a landfill site here in the UK. And we have one of the largest mobile filters available on the market. It's a 30-cube Voxorber. And we designed this a few years ago specifically with the biogas industry in mind, particularly landfill gas, where you have a flow rate of, say, up to 5,000 cubes an hour and a reasonably heavy loading of impurities, siloxanes, H2S, that type of thing. And this large vessel gives you a much deeper carbon bed. It gives you good kinetics, so good contact between the gas and the carbon in order to filter it out. And flow rates typically up to and above 5,000 cubic meters per hour. And we supply that on a full service capability. And we can assist with, obviously, carbon filter installation and removal. You see one of our site service vans there at that site. As I mentioned, we have 3 waste transfer stations in the UK and 1 in France. So when the carbon is spent, we simply replace the entire filter with a new unit, and we'll empty the carbon out into bags at our waste transfer station and return that back to the UK for recycling. So there's no carbon handling on site. We use experienced logistics partners, and we're active in one of the relevant trade associations, the Renewable Energy Association. They have a biogas group and a landfill gas group. So why would you want to use activated carbon in the biogas sector? Well, as you may have seen in my presentation yesterday, you want to remove impurities. Typically, these are hydrogen sulfide, H2S, siloxanes, and other VOCs. In terms of biomethane sites, this is to purify the gas prior to grid injection. But in terms of CHP engines, you want to reduce the engine maintenance. That means fewer oil changes, prolonging the life of the assets. And this can be important, especially in landfill gas, as the volumes decline and the impurity mix might change. It's important to have good protection for your engines. And you don't want to invest in new engines as the life cycle of a landfill declines. Carbon filters can cope with varying gas qualities and quantities, so we can adjust the carbon type and quantity to suit the conditions of each customer site. And you can increase or decrease the number of filters to suit changing conditions too, so it's very flexible. In addition to biogas purification, of course, another classical application for carbon is general odor management. We all want to be good neighbours, and increasingly, this buildings coming up close to biogas sites and landfill sites. So it's important to remove odours wherever possible. So one case study at this stage, again, I showed this yesterday, so I apologise if you've seen this already. When we launched this large filter, this 30 cubic meter Voxorber, the very first unit went up to a landfill site in Scotland. And previously they had no engine protection at all at that site, and they were changing the oil on the engine every 150 hours. So you can imagine the expense and the hassle that was causing. After they installed our filter, the oil change out increased to every 1,000 hours, which meant reduced downtime, maintenance costs, and consumables. And the customer reported a saving at that site of over about £1 million per annum, so a very significant saving at one site only. So we work extensively with the UK landfill biogas sector now, supplying these types of vessels. As I said, wherever possible, we recycle carbon at our site at Immingham in North East Lincolnshire. We have a capacity of around 8,000 tonnes per annum following our expansion in 2018. By a factor of 3 times, that's one of the biggest industrial kilns in the UK, and it's actually one of the biggest amber waste kilns in the whole of Europe. So we did invest heavily in a very big kiln with a view of expanding the business going forward. The technology, if you're interested, it's called an indirect rotary kiln. You can just see it on the top right-hand side. It's basically a horizontal kiln. The spent carbon is on the inside, and the heat is applied to the outside of that metal tube. And it's a very efficient, flexible technology, more so than some other technologies like a brick-lined kiln. It has lower energy requirements, and it's got a very quick startup and shut down. So we think it's a much more flexible system. Being amber waste, of course, it does generate emissions, so we have a very sophisticated scrubber system to ensure environmental protection, and again, being good neighbours. And the big orange beast at the bottom isn't a submarine, it's actually our thermal oxidizer, which is next to the reactivation kiln. Our kiln can cope with heavily sulfur-loaded spent carbons, which is a particular issue in the biogas sector, and we always have ongoing research and development to try and enhance that capability. We know that is a particular problem in your industry. It's a big industrial site. We have on-site technical support in terms of engineering, R&D, and QA. So it facilitates quick maintenance and solving problems as and when they arise. And as you can imagine, that was a big investment. We've invested over £10 million sterling since 2013 in the 2 kilns, plus a number of skilled jobs. So we're very proud of our capability and the growth we've had. So why bother? Why would you want to reactivate your spent carbon? Well, firstly, performance. It does maintain excellent VOC performance, and that's especially true for cyclic siloxanes. And if you're not sure what those are, I'll show you those a little bit later. But for biogas applications, a regenerated carbon is very good. Carbon footprint, we've calculated that certainly with our technology, the carbon footprint of using a recycled carbon versus a virgin carbon is more than 90%. So that's very important in terms of your environmental message. Of course, once the carbon is in Europe or certainly in the UK, it stays here. So you're reducing the importation and reducing product tourism. And with a central location on the east coast of England, it's very good for many of our UK-based customers. Of course, there are economic benefits as well as environmental benefits compared with virgin carbon. If you use virgin carbon and throw it away, you have hazardous landfill disposal fees, or you might have to incinerate it. There's another factor that's certainly become relevant recently is virgin carbon price increases. 2 of our major global competitors have just this month put up their prices by up to 10% on all their virgin grades. And so by using regen, you're protecting yourself to a certain extent from those increases. So a little bit more about our mobile carbon filters, which are designed and built in-house. So there's a selection of pictures on the right-hand side. You can see the range, some of the ranges there. As I say, we have a department called CPL Icon here at Chesterfield, where they design and build these facilities. We supply them mainly on a rental basis. We can sell them too, but our business model is to basically rent these vessels out, and that obviously avoids capex from our customers. We take the capex hit. We have a large fleet, an expanding fleet. The overall range is called Clean Flow, which is our brand name. Within that, you have Aquasorbers for liquid phase and Voxorbers for the gas phase range. And they range in size from small drums, single-use drums, 180 litres. You can see that on the far right-hand side in the middle. It's one of our small drums, right up to our biggest vessel, which is a 30 cubic metre truck-based system. And you can see that on the top left-hand side of those pictures, 3 of those in a row there. That's for standard applications. We also have specialised, what we call high-flow variants, not so relevant for pure biogas purification, but for things like waste transfer stations or heavily VOC contamination at a chemical plant. We have vessels that can cope up to 45,000 cubic metres per hour. And I'll have a slide on those just in a moment. So looking in more detail at our Voxorber range, so these are our gas phase filters. I just laid out the main styles we have there, starting with the AT1 drum on the left, 180 litres, 250 cubic metres per hour, and it's designed as a single-use carbon filter. Then moving up, if you have a larger flow, say 1,500 cubic metres per hour of biogas, we have the 2 metre cube Voxorber, has a ton of carbon in it, and it uses our regen service. So that's this, when the vessel is spent, we replace it and take the vessel back and regenerate the carbon. We call that Regensys. Moving up in size to our 5 cubic metre vessel, takes 2.5 tonnes of carbon, Flow rate is a little bit higher at 2,000 cubic meters per hour. And again, that's supplied on a plug and play Regenesis system. The examples you see there have actually one inlet at the bottom and 2 outlets, one at the top and one in the middle there. We've designed it that way because certain customers like an outlet at the top of the vessel and some prefer it lower down. It's simply the case of what is their existing pipe work and what's the easiest way to connect it through. It might seem odd having 3 ports, but that's simply a practicality that customers seem to appreciate. And on the right is our big vessel, the 30 cube Voxorber. That's at a landfill gas site in southern France, with flow rates up to 5,000 cubic meters an hour. So it's a big step up, but for larger sites that's required. And it's also used at biomethane sites as well. I mentioned briefly our high flow range. Again, this is typically for waste transfer stations where you need to change the entire volume of air inside a building. There are various sizes. These are different technology. These aren't deep bed. These are either annular beds or other technology inside them. It ensures a good contact with the carbon, but without a huge pressure drop that you'd get with a traditional deep bed vessel. And our current flagship is at the bottom there. That's the HF24. So it's based on a 30-foot container, 10 meters, and it contains 24 cubic meters of carbon and takes gas flow range up to 45,000 cubic meters an hour. It does take a lot of space, 30 foot, but we're developing a vertical version as well at the moment, which we'll be launching very soon. So what's the benefit of using these mobile carbon filters on a rental basis? As I mentioned, it avoids capital expenditure for the end user. The vessels are generally rented. There's no on-site carbon handling. It's simply a plug-and-play concept. They turn up full of carbon, attach it to existing pipework, and when it's spent, it gets changed out. It's a modular system offering a flexible solution. So as I mentioned before, you can add and remove filters as required. If there's a spike in contamination, you might want a second filter, or if it's a landfill gas site and the volume of gas goes down as the site gets older, you can perhaps remove a second or third filter. And if you have multiple filters, you can have them set up in different ways. You can have them in parallel, that's particularly if you've got a very high gas flow, or you can have them in series, which is what we call a lead and lag arrangement. So the front vessel takes the punishment, does the hard work, the heavy lifting, and the second vessel acts as a polishing filter. But it means you can work that lead filter through to exhaustion. And when you come to change it, if it's properly connected through pipework, it means you have no downtime. You simply swap them around. The second filter becomes the first filter, and you change out the first filter. So it's very flexible, and that's a system we do recommend for many customers. As I mentioned, different sizes are available to cope with different flow rates and various contaminant levels and types. And as I mentioned on the previous 2 slides, you can see the different sizes: 2 meter cube, 5 cube, 30 cube. And just for information, that bottom picture there, that's a landfill gas site here in the UK that had previously 6 2 cubic meter Voxorbers, 1 for each of their engines. But now they've changed those out now, and they have 2 of our larger 30 cube vessels. And that's given them quite a big saving and process improvement as well. So a bit more about the big beast, the 30 cuber. It's again, being a large filter, it gives you more usable bed volume. So the gas simply has more carbon to get through. So you've got more chance of removing contaminants. And that's particularly true with impregnated carbons, taking out things like H2S. It's delivered, as you can see now on that picture at the top, by a dedicated tipping trailer. And the partners we use for logistics, they're really skilled. They can deliver these things on a sixpence. They're very, very accurate and take very great care of customer sites. Flow rate on them is up to 5,000 cubes an hour. It doesn't have to be that high, but that's what the top end of what you're looking at. So for big sites, that is a very useful feature. And again, I think it's bigger than most of our competitors' range as well. We designed it specifically for the biogas sector. We saw a need in the market for these types of units, and that certainly has proved very successful in the last few years. There are many benefits of using these big filters compared to a smaller filter. Obviously, you have fewer carbon filter changes, which is great for your process and your cost base as well. And there's less road mileage and carbon footprint. We did a comparison for one customer comparing the 30 cube with our next small vessel down, it's the 5 cuber. And there's approximately a 50% CO2 saving by using the big filter with fewer exchanges. It's a flexible unit. It can cope with various gas flow changes. And you can even mix carbons within one vessel if you want to. So you can have a layer for hydrogen sulfide and a layer for your VOCs and your siloxanes. So it gives you a lot of flexibility. As I mentioned, if you have more than one filter, you can have it in what we call a lead and lag arrangement. So the gas goes into one filter, comes out of that filter into a second filter. And we do suggest this arrangement for many customers, especially with a higher flow or if they have particularly heavily contaminated biogas. It gives you optimized contact time between the gas and the carbon and improves your bed kinetics and ensures maximum removal efficiency. And as I said, if you pipe it properly, then you get total protection at all times. You do not have to switch off your engines. You simply direct the gas through the second filter to change the first one, and then you replace it, and vice versa. The second vessel is basically a polishing filter, but it allows the first vessel to run through to exhaustion. So you can basically get the maximum bend potential out of your carbon filters. It reduces the number of changes and reduces the cost significantly. So we always suggest, especially if we're involved in the pipework installation, to allow for multiple filters. Even if a site only requires a single carbon filter initially, if they're unsure about it going forwards, if you make the pipework available for multiple filters, it saves a lot of time and effort and cost going forwards. And we look at site by site. We work with our customers to look at their particular conditions and to get an optimized solution for them. I mentioned Regensis, so this is our overall carbon vessel recycling service. And this is the schematic we use to represent this. Starting in the middle, one of our vessel service centres. So these centres, they take an empty vessel and they fill it with normally recycled reactivated carbon. That's signified by the blue filters, and they're taken to a customer premises on the left-hand side, where they're used until they're spent. They become red, not physically, not actually, just representative, and they're returned to our vessel service centre. The vessels are emptied. The carbon is put in big bags and sent to our reactivation centre at Immingham, which you can see on the bottom there with our big kiln. And that's how the cycle works. We have a YouTube channel. I should mention that. We have lots of videos and animations on there. You can find out much more about our reactivation cycle and our different vessels as well. So it's an interesting thing to watch and find out a bit more about what we do. And we also have a website, of course. A little bit more about our design and engineering service, also with a case study here. So in addition to the vessels and the carbon, we have the capability to design and install all the necessary pipe work. And we do this pretty quickly, typically 2-week lead time from start to finish to get the design and to install the equipment. As I said at the start, we like to see ourselves as a one-stop shop for all carbon filtration requirements. The example I showed here in the pictures and in the drawings, this is a wastewater site in the West Midlands here in the UK. They did have a small siloxane filter, but it was less than 2 cubic meters, so that's smaller than our smallest Voxorber. So it really wasn't adequate to take out siloxanes on a big wastewater treatment plant. So they went up to our largest filter, which is quite a big jump. But because of the physical constraints of getting that filter in, it needed additional pipe work and connections. So as you can see, all the drawings are there, and the finished article looks exactly the same as the drawings, which is always what we hope. And we did all that ourselves. And more generally, not linked to this particular project, but as I say, we will try and future-proof your installation by installing pipework for multiple filters, even if a single filter is installed initially. A bit more about engineering services. This is another customer in the wastewater sector. This site has actually had a lot of publicity on social media recently as well, so it's been in the news a bit. This is in Northern England. So it's a biomethane facility using water wash technology, and I think you probably can see my mouse, but that's the water wash tower there. It's obviously different technologies for making biomethane. It could be a membrane system or water wash or other things. For membrane systems, so not this one, the carbon filters tend to be up front to take out the H2S and protect the membrane. But in water wash, in this particular case, we installed 4 high-pressure carbon filters to polish the biomethane after the water scrub. So it's basically as a final step before injecting into the grid. And we did all the interconnecting pipe work, which you can hopefully see at the bottom of the picture there. And also this large unit on the left is a fixed, it's a large odor control unit for the off gases as well. So yeah, we had very big involvement in this project, 4 carbon filters, all the pipe work, and an odor control filter. So we're very proud to be involved in that project. That was only just last July, just over a year ago. So that's a bit of overall about our product and services. I want to talk in more detail, if you'll allow me, about actual product selection. So which carbon, what is carbon, and how do you select the right one for the job? So what is activated carbon? It's a very pure form of charcoal with a very high surface area. When I say high surface area, we're talking about a teaspoon of carbon having a surface area of about a football pitch. So it is quite amazingly extensive surface area. It's made out of various carbonaceous raw materials, principally coal, coconut shell, and wood. We're always looking at other biomass raw materials as well. And each of those raw materials gives a carbon with different properties. So it's important to work with carbon suppliers to choose the right one for your application. Mostly for biogas and gas phase application, it tends to be coal-based carbons. And they come in different physical forms. You may have heard of these abbreviations: GAC, granular activated carbon, powder carbon, and extruded pellets. So in gas phase, you typically look at extruded pellets and increasingly large GAC. And you can see an example of both at the photo at the bottom. And the photo at the top is obviously a micrograph of the surface of activated carbon. So I talked about the surface area, but actually that surface area is made up of lots of internal pore structure. And it's those pores that actually trap the impurities in a gas or liquid phase stream. And the process is called adsorption. That's with a D. It's different to absorption, like a sponge taking up water. This is just on the surface and in the pores. And generally, this is a reversible process. So that allows for us to thermally reactivate the carbon, to recycle it. You put it in a furnace at 800, 900 degrees, and those impurities are released. They're desorbed and they're destroyed in the thermal oxidizer. So your standard carbons are ideal for organic impurities, so your VOCs, your volatile organic compounds, and particularly siloxanes in the biogas sector. However, if you have other contaminants, inorganic or polar molecules like hydrogen sulfide, ammonia, mercaptans, formaldehyde, for example, then you can modify the surface of the carbon with chemical impregnants. We call it impregs or impregnated carbons. So basically, you can offer a product for most gas phase impurities. It's a well-established technology. It's been around for a long time, but we're always with our R&D looking at the next generation, the next improvement, the new raw materials, new applications. And the carbon is often used with other technologies as well. We know it's we don't see other technologies as competing; they're always complementary. A bit more detail about the contaminants you're likely to face in biogas. They basically come into two broad areas: the organic compounds and the inorganic compounds. Organics, often referred to as VOCs. Typically, these are siloxanes, so you'll find these in many consumer products like toothpaste and consumables like that, and also in the wastewater stream. Pinene is a compound you'll find in domestic cleaning products, and limonene is in citrus type products as well. So those typical VOCs you find in a biogas stream. Siloxanes in particular contaminate engine oil and cause frequent expensive oil changes. And siloxane, one of the molecules is shown at the bottom, it basically deposits silica, it deposits glass on any hot surfaces. So that can cause enormous damage to CHP engines. And that was the subject of the presentation yesterday morning. So that's a perennial problem in the biogas sector, one of siloxanes and other VOCs, of course. And moving over to inorganics, the most common always is hydrogen sulfide that's formed by any decomposing organic matter. Others might be ammonia, for example, if you're using chicken litter or whatever, but H2S, hydrogen sulfide, is a particular problem. It's corrosive to the engine, it can form sulfuric acid, but it's also odorous and toxic. So, of course, you'd want to remove it to a great extent as possible. Traditionally, landfill gas, which is a big sector for us, the siloxanes are the main problem, but we are aware that going forwards, hydrogen sulfide is becoming more of a problem in some landfills as they get older and then the waste gets more concentrated. But both of these types of products can be effectively removed with activated carbon filtration. That's the message today. The slide on siloxane types, I don't need to go into too much detail other than there are two broad families. There's the cyclic ones, as you can see, obviously named at the top. There's various ones there, and then the linear ones where it's an open chain. I'll just draw your attention to this top one, we call the L2, hexamethyl disiloxane. That's one I'll mention in a case study just in a moment. So when it comes to solving a problem with carbon filters, often you have to have a balance between siloxane or VOC and your H2S removal. So you have to ask the question, which is causing you more damage? Where is your pain? Where's your pain point with your process? If you've got both, then you might choose to use a lead and lag, have two filters, or even a mixed bed using standard and impregnated grades. So again, we will work with our customers to choose the best solution for whatever problem you have on your site. For siloxanes and other standard VOCs, we offer normal non-impregnated carbon, and these are either virgin grades or regenerated. As I say, we try to promote regenerated wherever possible. Virgin grades are very good for linear siloxanes. where they have a different pore structure and then it suits the linears better. So our grades for those would include CX64, which is a granular grade, and EX64, which is our 4mm pellet. Regenerated carbons are very good for cyclic siloxanes. It's a more open pore structure, which suits the larger cyclic molecule. And the grades we offer for those, CXR4, the R stands for regen, that's the large granular, and EXR4 is our large regenerated pellet. And yeah, large granular or pellets, you've got to think about pressure drop and contact time. All these factors we will discuss with you on a case-by-case basis. And just on the right-hand side is a fairly recent landfill gas. In fact, that was the site I mentioned before where they had six small filters. Now they've got 2 large filters, and we did all the pipe work there as well. And we've arranged that, as you can probably tell, as a lead and lag arrangements, or parallel, whichever they need. But basically, it ensures no can redirect the gas and not have any shutdown of the engines. That's set up. Quick case study of a landfill gas with siloxanes. The total siloxane was 264 milligrams per cubed, but the main problem clearly here in the numbers was this hexamethyl disiloxane, the L2. That was causing the main problem. So that's the gas quality before the filter. I'll just flick down to the gas quality after the filter. Took it out completely, so the total siloxane went down to 264, down to 3. So no problem at all for an engine to handle that. So that was a successful application, and that's typical of taking out siloxane from biogas streams. Whoops, sorry, I'm just going a bit twitchy on the number there. So moving again on to inorganics, hydrogen sulfide and other inorganics. So these, as I said before, require impregnated carbons. So you're promoting a chemical reaction on the surface, which we call chemisorption, rather than pure adsorption. It usually requires a bit more contact time between the gas and the carbon as well. Again, that's a benefit of having a very deep bed filter. The selection of products, and there are many products available to do this, depends on process conditions, particularly oxygen levels, which I'll go into in a bit. It does get quite complicated at this point, but process conditions have a big impact on your selection of products, as well as the impurity you're trying to target. And humidity and temperature affect it too. It's a chemical reaction, so of course it's affected by temperature. And humidity does impact on carbon performance. If you get humidity trapped in the pores, that will reduce the usefulness of the carbon pores itself. So listed up here, some of our main impregnated grades used for gas phase applications. So that's including biogas, plus also more generally odor control, because the impurities are the same ones. So the thing to look at really here is the oxygen level. So if you have more than 2% oxygen, so in effect plenty of oxygen, we suggest a potassium carbonate impregnated carbon to take out your sulfur-based impurities like H2S and mercaptans. And the grade is called SA78 in our range. Going to slightly lower levels of oxygen, we use a copper oxide impregnated carbon, which is our SA70. And I know many customers in the biogas sector use that grade. Lower levels of oxygen still, we offer a potassium iodide impregnated carbon. Again, we're talking here about sulfur-based contaminants. And our product for that application is SA63. And for very low levels of oxygen, we can offer a caustic impreg, and that's our SA62. So as you can see, these look relatively small changes, but it involves completely different product selection, and we work with our customers to choose the best solution. Other impurities, so nitrogen-based, amines and ammonia, we use a citric acid impreg, and that's called SA66. And for formaldehyde, which technically is an organic compound, but it's obviously very polar, doesn't stick very well to standard carbon, we use a sodium metabisulfite impregnated, and it's our SA67. So that's just a small selection of our main impregnated ranges, but again, please talk to us about what you need for your particular application. We can combine different impregnants, that's possible to give excellent performance, but of course, if it's bespoke, you have to think about the cost as well. And this is a performance demonstration for SA70. That's one of our main grades for taking out H2S. So this is under lab conditions. I do have to stress that because biogas is a difficult mix of lots of different things. Different molecules compete on the carbon for absorption. But in lab-based conditions, you will get up to 45% weight of hydrogen sulfide on the carbon, and then the performance drops off quite quickly. In the real life situation, it won't be as high as 45, but it just gives you an impression of how good these carbons are. And here's a worked example. This is where we used SA70 for the removal of hydrogen sulfide at a biogas site. The customer had their own fixed filter. It's 4.5 tons. The gas flow was just short of 2,000 cubic meters per hour. And at the inlet, the H2S was just short of 1,000 milligrams per cube. With our carbon at the outlet, the concentration was down to 22 milligrams per cube. So that's a 98% removal efficiency. And the time to breakthrough was over 500 hours of operation. So again, that's a very good example of where the selection and the application really worked for the customer. And they achieved 32%. So again, it's not the lab-based 45, but it's still a very good score. That's a quick run through then of our products and services and our other grades of carbon and what you might want to consider when selecting one. So to conclude, we are a leading supplier of carbons and services into the biogas sector. We can supply carbon anywhere, but here in the UK, we're the only UK-based supplier to offer all of these services. So, local production of impregnated carbons, reactivation of spent material from industrial processes, in-house production of carbon filters, full engineering capability, backed up by a nationwide site service, also backed up by technical R&D, QA lab support if that's required, and quality accreditation. And it goes without saying, we're keen and we're ready to work with all biogas operators out there to protect your assets and improve your plant efficiency in a safe, cost-effective and environmentally responsible manner. So thank you ever so much for your attention. I hope that was interesting and look forward to discussing with you in more detail.